A to the power of 4, it is easy. We can easily find it. However, 0.1. They gave a different, difficult to understand result. The reason of this, I can explain it to you in a simple example. If we take a square root of -1, what we get are the results like this. We have 3 results. Of course, sometimes we may prefer this result, but in Matlab you cannot get that one directly. What we get is this one. This is the complex number. So if you use this kind of notation, what you get is this one. So the problem is, how can we get others? Remember, there is a rotation formula. We can multiply them by I to the power of. Now remember, like this code. Oh, so I haven't got the code. Here it is. Suppose this is the original matrix. So what we need to do is to iterate it directly and then use this command to get the cubic root of it. And here we can make a third power to C and compare it with the original matrix and see whether they are the same and take the error between them. They should be the same, but with the numerical computation there should be errors. So let's see what is the error. The error is something like this, 1 to the 10 to the minus 15th power. So it's small enough. I don't think there is an equivalent thing for for symbolic computation for this kind of problem, because I don't think there is an algorithm to do so. So there is no problem with the first cubic root of it. There is no problem with this one. So how can we get this one? We just perform simple notation here. 3 j 2 times j pi. Multiply this one, you can get this root. And if you further multiply this, you can get this one. And you can check the result. There shouldn't be any problem. So in this case, we can easily find the power of a given matrix. And so if we use the rotation way, we can find all the roots. So this is the difference of my book and the Matlab manuals. Matlab manuals always give you this one. It does not teach you how to get others. But if you teach mathematics, you have to consider how to take others. So you have to write command like this. So this is the difference. There are some logic operations. For instance, we can take and or not or something like this. And these are useful in programming. And the notation is something like this. I think I missed one point. The dot operation, which is quite useful. This is the dot operation. A dot times B. It is different from A times B. It is an element by element operation. For instance, if you perform this one, the ij's and the ith row j's column elements of A is multiplied by ij's element of B and forms elements of C directly. The corresponding terms are multiplied together. I shall give you an example. So what is A times A? That's A squared. It is something like this. It follows the mathematical formula. So what is A dot times A? It is given like this. Each number is squared. It's A squared because we use A times A. So the element by element operations are needed. Why we need such a element by element operation? I can give you an example. If you want to draw a picture or a graph of x squared plus x cubed, if you try to draw the graph of this function, what you need to do first is to define the x-array of x vector. So what you need to do is x equals 0, 0.1 up to 1. And the brackets are not necessary, you can omit them. So x squared means that for every element of x, we have to take a square operation. And this one also, for every value of x, we have to take the cubic operation. So we cannot use x hat 2. We have to use x dot hat 2. So these are useful in drawing graphs. So in this case, we can find the y and plot them together. So we can immediately draw the curve of the function like this. So in real applications, you must be very careful with this kind of dot operation. And dot operation is not restricted to this kind of operation. It can also be used like this. And also A can be replaced by an integer or other element. So these are the dot operations. Now let's consider the logic operation. We do not often perform logic operation to matrices. What we need to do is just the two scalars normally to perform and or not operations, or exclusive operations. And this can be done by this kind of symbols. Slightly different from the case in C operation. In C you have double and so on. So these are the logic operations.